FLYHT Aerospace Solutions, and the name again is a pretty strong hint of what it does. Some of you may remember this by its previous name being Aeromechanical Services. FLYHT has come through its own rocky road, in fact more than about 10 years now. But it does have a new technology that does what no company does under one umbrella, and you will see this at the beginning of its presentation. So how good is this technology? You may have heard of a company called Airbus, and you may have heard of a company called NetJets. And NetJets has a European division that FLYHT is doing business with. And by the way, NetJets is part of Warren Buffett's international business jet operations. And then there's L3 Communications that happens to supply most of the world's black boxes. FLYHT and these names are all aligned now. So there has to be a reason that these multi-billion-dollar companies are saying there is merit in this technology, and it's worth our effort to align ourselves with this little Calgary company, and they wouldn't do it unless they thought they could make a dollar at it. The older technology that FLYHT developed is now on over 250 aircraft around the world, and that happens to be a microscopic percentage of its potential market. It has a recurring revenue model and gets a monthly check under multi-year contracts. FLYHT has important and very influential institutional investors that have shown a lot of patience and continue to financially back the company because of what the company is becoming and can become. And you'll see something in here that FLYHT clearly states that they believe that 2013 is the start of something big. FLYHT admittedly does have some work to do on its balance sheet, and management is hoping to come up with a creative answer to that in advance of year end. Management owns about 5% of the 140 million shares issued. It's currently trading in the 20-cent range, and the average daily volume last year was about 136,000 shares and just over 91,000 this year. And interesting enough, in its former self as Aeromechanical Services, FLYHT used to be a client and then became a client again just this past fall. With that, I would like to first introduce Tom French, who's the Chief Financial Officer of FLYHT, and then call on the Director of Advanced Applications, Kent Jacobs.
My name is Kent Jacobs. I'm Director of Advanced Applications at FLYHT. I was the original employee, so my background with the company is 12 years now. Back then they had enough money for one person to hire, the founders of the company. They needed a pilot who could cut code, and that suited me just fine. I had been working up north flying, and my background is in computer science. This presentation has forward-looking statements, as the rest of them do. The presentation and some of the comments I make will bear that. So for the first time in history, live data can be instantly streamed to and from an aircraft anywhere in the world. That's an interesting statement because it catches a lot of people off guard. There's a preconceived notion that aircraft anywhere on the planet are connected, both with data and with voice, to operations on the ground. There's the perception that the aircraft is connected to air traffic control, to their operations center, and to maintenance control. That is simply not the case. Air-to-ground communication has not changed much since World War II, and 75% of the world does not have radar or VHF radio communication to the aircraft. So the oceans are not covered, the deserts, the North and South Pole are not covered. This came to light in 2009 with Air France 447. I don't know if people are familiar with that. It was an Airbus A330 aircraft operated by Air France. It left Brazil on its way to France. It disappeared in the Atlantic, and it was 7 hours before the operations in France knew that the aircraft was in the water. Not only were they delayed in getting any kind of emergency response out to the aircraft, they didn't know where the plane went down. It seems impossible, but we had a modern airliner that went into the water and nobody knew where it was. The effort to find the black box, the flight data recorder and the voice recorder was more than 150 million euros and took more than 2 years. During that time, the BEA, that is the Accident Investigation Board of France, began work groups where they invited companies and industry experts to come and talk to them about how they might better get information off of aircraft and how they might keep communication with aircraft while they're in flight. FLYHT was asked to join those, and it gave us an opportunity to present our technology not only to the accident investigation boards around the world, but also to large aircraft OEMs at those presentations, airlines, and other competitors. It was kind of a growing up phase for FLYHT. It was an opportunity for us to present our technology in a way that most of the world had not seen. What turned out is that our technology is unique. By using our existing product and the new product that we have just developed, the AFIRS 228, and I'll go into that in a few minutes, we were able to stream that FDR data, or demonstrate that we could stream that FDR data off of an aircraft in flight. It was a changing point for our company. So a couple of investor highlights. With our new technology, we now have an unparalleled system that saves money, time, and drives efficiencies in the airline industry. Airlines are not typically used to knowing or having the ability to interface with their aircraft in flight the way that we can offer. We have more than 1 million operational flight hours. So to get to 1 million hours, we have to have a significant installation basis, and we have to have been operating for a while. We think that we are now positioned to secure some large multi-aircraft contracts. With our original AFIRS product, we wouldn't have been able to do that. With the new product that we've developed over the last few years, we are making that transition. We have a proven recurring revenue model with multi-year contracts. In 2011, 54% of our revenue was recurring revenue, and that's on average $1,500 to $2,000 a month per aircraft. We have absolute customer satisfaction. We've never had a customer not renew a contract that's come up, and we've only lost the odd airplane due to bankruptcies of airlines. What's interesting is some airlines that go into Chapter 11 protection actually mandate us as a necessary service, so we continue to get paid while they restructure. That's a real credit to the information that we're providing the airline. Some more highlights. We now have a strong contractual relationship with some key players, and this has changed our company. This is that maturing process. L3 Communications, Airbus, and NetJet Europe. These are leading companies in this field. They changed the way that we're perceived, and with their help and their support, we're actually now growing up. We're not the 45 people in Calgary anymore. We're recognized as a real player. We have technology patents in the most important jurisdictions. So Europe, US, China, Canada, Brazil. We're covered both with our technology and with our method. This gives us numerous competitive advantages, and in 2013, we think we're going to be able to make the changes that we need to. Our flight technology is called the AFIRS unit. This stands for Automated Flight Information Reporting System. This is a product that goes into the avionics bay of an aircraft and interfaces with various data buses. Some of those buses are the same as the ones that go to the flight data recorder. So in the aircraft, you've got a stream of data that goes to the black box. You've also got the identical stream going to our product. In a modern airliner, that's about 3,000 parameters a second. All of that data comes into our system. It gets converted into what we call engineering units. That's the real world unit, so it's decrypted and decoded. And we draw conclusions about the way the aircraft is being operated. Now, with 3,000 parameters a second, you can imagine what you can do with that type of information. You have everything that you need to know about the way the engines are being operated, everything about the fuel systems on the aircraft, everything about the airframe itself. We're able to actually draw conclusions and then send that information down to the customer. And a few slides later, we'll see how that works. The AFIRS product works on any aircraft. So we have one line of hardware that we produce. It's configured differently with software, and that's how we go onto the different aircraft types. So we currently run on Boeing 747s, 777s, Airbus aircraft, A320s, A330s. We're on old Fokkers, DC-10s. The range is huge. We're all with the same hardware, but we have different software configurations. The new technology also allows us to use existing systems on board the aircraft and make them more efficient. So rather than try to knock off some of the kind of legacy systems on board an aircraft, We now provide a means to move their data for them off the aircraft more efficiently than they can do themselves. We have continuous monitoring. All those parameters are being analyzed all the time. We use the Iridium satellite network. Iridium is a low Earth orbit network. It provides true global coverage. There are several satellites in the network, 66, and they communicate with each other. There are no gaps over the poles. There are no gaps over the oceans. So other technologies, other satellite networks don't provide that full coverage that we have with Iridium. Through Iridium, we do both voice and data communication. So the single AFIRS 228 product offers voice communication for the cockpit and the cabin, for the flight crew in the cabin, and data services for the cockpit. There's an interesting quote there. It's a 6-pound heavy weight that will drive a cultural change on how an airline operates. It's very difficult to influence changes in this industry. We've been working on it, and as the airlines begin to recognize that they now have access, they have a window into their aircraft while they're being operated, they're coming up with the ideas that we need to help generate the recurring revenue. This is a marketing slide showing the connected aircraft. These are some of the services that we offer, and I won't go into all of them, but a couple of them are really worthwhile pointing out. Engine trending in the bottom right-hand corner. Engine trending is typically done, it's a manual process. So the flight crew at some time during a flight will stabilize the engines, the aircraft will be in a stable condition, and they will record maybe 5 or 10 parameters on an engine in a logbook. That information is collected over the months and the years, and eventually it ends up back at an engine OEM where they draw conclusions about how the aircraft is being operated, the engines are being operated. We gather that information at several times throughout the course of the flight, many more times than the flight crew could do it, because we take it during the takeoff roll, we take it 10 seconds after takeoff. We take it at times when the flight crew is too busy flying the aircraft to be recording this information. We've been sending that information to the 2 biggest companies are Rolls-Royce and Pratt & Whitney. And some of our customers who have been getting that information to Rolls and to Pratt & Whitney have been able to actually reduce the number of inspections that they have on the engines and reduce the number of times that they take the engines off the wing. One customer had to maintain an inventory of 8 engines in their fleet, just 8 engines on the ground in their maintenance operations center, so that when they needed to, they could pull off an existing engine and put a new one on. With the information that we send to Pratt & Whitney, they've brought that down to 1 engine. That paid for the system, for our system, on that fleet of aircraft for 5 years. Just that one functionality. We have a fuel management program where we monitor the way that the aircraft is configured on approach and departure. You can burn the entire revenue for a flight by hanging the gear and the flaps out too long, for too soon during an approach. So when you come into Calgary, if you're 25 miles out and you're configured for landing and you level off the aircraft, you actually have to increase the power so that you can just maintain your altitude. By monitoring that information and feeding it back to the airline in a way that they can actually make conclusions, they can draw conclusions and see the way their aircraft is being operated, they're able to change the way that they train their pilots. Some other items in the connected aircraft are electronic flight bag connectivity. You might have heard that American Airlines purchased 11,000 iPads for their flight crews. Those iPads are isolated once the aircraft starts to move. So as the aircraft pushes back from the gate, the iPad is not connected to anything. It's just a tool that they can use on board the aircraft. Our system can interface with the iPad in flight, move data from the ground and from operations to and from it. The AFIRS unit goes on board the aircraft. It's installed in the avionics bay. It analyzes 3,000 parameters a second. Once it draws a conclusion about the way that the aircraft is being operated, it uses the Iridium network to move small amounts of data off of the aircraft to our ground-based system. Our ground-based system is called Uptime. Uptime archives that information, makes it available on the line, on the web to the customer, or it feeds other systems. We talked about the Rolls-Royce and the Pratt & Whitney system. Always connected anywhere, anytime. We just passed 1 million hours a few months ago. This is a snapshot of some of our aircraft at the time that we passed through 1 million hours. We fly to all 7 continents right now, including Antarctica, where we have an A319 operated by the Australian government that goes there on a regular basis. Some usage numbers from 2005 on. Total customer flights, we're over 700,000 now. Total revenue is over revenue flight hours is 1.1 million. We're averaging over $10.50 per flight hour. And our total recurring revenue is coming up on $12 million now. Some massive barriers to entry. I should be careful. These are barriers that we've overcome, not ones that we still have to overcome. Aviation is a highly regulated industry. That is a real problem. We've overcome that over the last several years. We hold several patents. We mentioned that. We have something called a supplemental type certificate, which is a modification to the operating certificate of an aircraft to install our product. We have an engineering staff in-house that generates these supplemental type certificates so that we can install on any aircraft around the world. Each STC has to be certified and authorized by the various regions. So we have to go to the FAA, to Transport Canada, to EASA in Europe. It's a never-ending process as we do the retrofit market. We've also been developing the relationships with companies like L3, Airbus, and NetJets over this time. We believe the market opportunity is huge. These are some statistics for commercial and business aircraft. In this context, commercial aircraft are Boeing and Airbus only. So in 2010, just over 19,000. By 2030, coming up on 40,000. And the business aircraft increasing to 31,000 by 2030. This does not include turboprops or military transport aircraft. So the Bombardier Dash 8s, the de Havilland Dash 8s, the ATR aircraft, the C-130 Hercules, those are not included in these numbers. Our business model is to put the AFIRS hardware on board the aircraft. We make money when we put the product on board the airplane. Once we get the box installed on the aircraft with the antenna on the roof and do the full installation, we create the new programs that run on that AFIRS unit, and these will be specific to the aircraft type that we're on. We can control that software on the AFIRS unit from Calgary. We actually use the Iridium network to update the software real-time from our Calgary center. Usage, the last box in this case, is our uptime system that receives all that information and feeds the various applications that a customer or an airline would like to see get the data. Invited to the table, L3 Corporation. We've been working with them since 2009. With L3, we won the Airbus A320 contract for the Iridium solution. L3 is licensed to build, certify, and sell our product. We make the recurring revenue on all of those installations. So we're finally moving into the OEM installations. And this is important because we now have the retrofit market with our engineering staff to let us put the product on any aircraft, and we have we're starting into the OEM world. We signed our contract this year with NetJet, Berkshire Hathaway company, largest fractional operator on the planet, 650 business aircraft total. Our contract was for the 30 Hawker Beechcraft in Europe. So we got the entire Hawker fleet in Europe, $600,000 up front. It's a $6 million contract over 5 years, $60,000 a month in recurring revenue. That's less than 5% of the total fleet. In the past, we've talked a lot about China. There are just a couple of key points that I'd like to make about the China state right now. China has mandated that all aircraft will have a satellite communication system on board, and we are the only certified Iridium provider in China. That is an authority that we have from the Chinese government and the Chinese military. So when we put those two together, we know that the program is going to roll out. We're just not making projections on it anymore. We believe it's realistic. The timing is difficult for us to comment on. Gaining momentum. I really wanted to use this. The dark lines here represent the recurring revenue over the last several quarters, and you can see that it's fairly level. Part of that is because we've had such a strong research and development push, and we haven't been developing as much of the applications that help us with the recurring revenue. As our research and development is tailoring off with the new product, we're able to increase this by adding new programs that the customers will be buying. Two big challenges that we've had. We lost, with the end of the war in Iraq, we had specialty carriers in the U.S. that were moving a lot of troops back and forth between the U.S. and Iraq. 36%, not of our total revenue, but of our total revenue from those customers went away through that. Another challenge was that our original product, the AFIRS 220, was not capable of being incorporated into the Airbus OEM line. That changed with the AFIRS 228, so the new technology that we're just releasing. A quick review of the financial and share summary. 140 million shares outstanding, 5% for the insiders. I'm just going. Our research and development is really coming down. It's been coming down significantly over the last quarter, the last 2 quarters, and we're able to deflect just a tiny bit of that money into the new programs that we want to run. A quick summary of the recent achievements. It's the L3 and the Airbus contract that is a major one, along with signing NetJets for the entire Hawker fleet. Technology breakthroughs, the 228 is capable of standing on its own, doing everything that the original product did, but it's also able to interface with other systems on board the aircraft and provide a means for revenue generation that was just not there for the 220. The last slide, management objectives, is to be cash flow positive in 2013. Airbus will owe us, they owe us forecasts for 30, 90, 180 days by the end of this year on the projected sales that we'll have in the OEM market. We plan to land a major Airbus operator for retrofit in the first half of 2013, and we want to be shipping out of 2013 for those Airbus operators. And the last point there is to grow our recurring revenue. Thank you, and apologize for the rush.